This is the screencast for section 3.2, example 4. You're going to love your calculators again. Now, keep in mind, as I told you in example 2, just because you can find the derivative with your calculator doesn't mean A, that it exists, and B, that you get to use that very often. It's more of a way just to be able to check your work. You still have to show your work a ton. It is going to be very rare that I ask you to either find a derivative with your calculator or, like example 4 here, graph a derivative using your calculator. You will have to graph derivatives by hand usually, so don't lose sight of how to do that. Being able to use the calculator is great, but as they say, with great power comes great responsibility. So make sure you're responsible and still knowing how to do all this stuff by hand. Example 4 says, let f of x equal the natural log of x and use NDER to graph y equals f prime, so graph the derivative. Can you guess what function f prime is by analyzing its graph? Well, if you want to, first of all, graph a derivative in your calculator, you go to y1 and then you do math 8, so the derivative of, put your function in. Now instead of saying x equals 2 or x equals 5, a specific a value, that would just give you a horizontal line. It would give you the derivative at that specific number for every x value. We want the derivative at every x according to the x that's being plugged in. So this process is doing your limit as h approaches 0 of f of x plus h minus f of x all over h by leaving x in it, and then at the very end it's going to plug in every single x value and then map out the y values. So this should be the graph that you get. Now looking at this, does that look familiar to you? One of your basic functions? To me it looks like the graph of 1 over x, and then with a little bit of tracing you'll see that if you plug in 2, the y value is 1/2. If you plug in 3, the value is 1/3. If you plug in 1/2, the y value is 2, etc. So we can make the conclusion that the derivative of the natural derivative with respect to x of the natural log of x equals 1 over x. However, you're like, wait a second, Ms. Larson, isn't there like a second half to this graph? Well, yes, but you can't take the natural log of negatives, so we're going to have to identify that this graph's domain is from 0 to infinity, and you can't take the log of 0 either, so we would have parentheses around that. The now try problem number 27 says using NDER, and by the way, that little process there is a little old school. Your calculators are definitely more updated since this book has been written, but it still is taking the derivative. To graph the derivative of the function, if possible, identify the derivative function by looking at the graph. Okay, so let's use our calculators, and we will put math 8, the derivative of, and then negative cosine of x. Make sure you're in radian mode. And then you can't see it here, but that's x equals x. So we're taking the derivative with respect to x for every single x value we can possibly plug in. Now that graph should look familiar to you. It's definitely taking on a sinusoidal rotation. If you plug in pi, you're going to get out 0. If you plug in 2 pi, you're going to get out 0. If you plug in pi over 2, you're going to get out 1. So we can make the conclusion that the derivative with respect to x of the function negative cosine of x is sine of x. Now that's not the only way you could write it. You could also say y prime equals sine of x, but you should be trying to practice the various ways of writing a derivative because you'll see all kinds of different ways.